Okay, I guess we'll call this part two of using Excel to find equations of tangent lines to polynomials. But today we're going to add on the area to that. So if you haven't seen part one, it's about a 41-minute video. This one's going to be probably less than 10. Um, so we're gonna add on areas between our regions. In this case, just negative 1.6 to 2 of this fifth degree polynomial with those parameters. You may want to pause this and take a moment just to get those parameters entered, because it might be reassuring for you to see that we have the same values as we start creating our trapezoidal areas. It's not so important that you have the x equals negative 1.15 and the 4. Thanks to Levi for yesterday. I did not save as I created the original 41-minute video. I did not save my file, which was crazy, but he did. And you notice he used a blue font in here, which is basically his way of saying, "Hey, these are formulas, buddy. Stay away from these." But anyway, go ahead and pause and let's get those parameters in. You should have a similar looking graph. You may want to put, if you want to see the tangent line, the x value, negative 1.15. So you could be in pausing now. Okay, welcome back from your pause. Hopefully you have a graph that looks similar to ours. Levi has a minimum, a maximum. Those are pointing back to these cells. He's done maybe a little bit more work here to get the word min in than we did the other day, but we'll be talking about that. We're also tomorrow in class, we're going to be talking about how we eliminate this minus negative. We'll probably put this equation in slope-intercept form. But today, on this video, I just want to get area of trapezoids. So I'm going to clear some space out. One of the cool things about Excel, there's so many. If I come up and take a look at this minimum, I notice it's looking at cell E20, which is right down here, and it's just picking this value and putting it into this word art up here. Now, if I grab all of this and move it, one might think that I'd lose that value. I'm just going to slide this over here, nowhere in particular. I just want to give myself some room. And I'm just going to drop it here. And this is smart enough to know I should follow that value, K21. This is like a parent value of this offspring, and the offspring just wants to follow the parent. So anyway, I'm going to go to cell D19, and I'm just going to type in trap, realizing this is going to be my area of the trapezoids. If we're going to understand this and not just do it, we should realize this is the graph of the blue curve. This is the graph of the line. I'm looking for the area under the blue curve. So I want to work with these values in the Y chart here. And my trapezoid is going to be, of course, the area of a trapezoid is the average of the bases times the height. And our trapezoids are going to be regions up in here. You go up to the blue curve, but the blue curve is changing. They're kind of trapezoids on their sides. My bases are actually the y values. So equals, I'm in D20, the average of the bases. My first base is this negative 7.5965 value, which you could be rounded to a different place, plus the next y value following it, close parentheses, divided by 2. That is the average of the y, of the, not just y values, but the average of my bases of the trapezoid, times the height of the trapezoid. I could get that by taking an x value here minus an x value here, but I can also get that by just stating, well, that's just our increment. That's how wide every step is of our 10,000 element T-chart. And I'm going to hit enter. Now, I'm going to go ahead and start the replicating process on this guy. But when I'm doing big replications, I just like to go a little bit, and I realize, ooh, I got some strangeness here. Let's take a look at that. Oh, I got an error message here, and then my values jump from something which is sort of believable up to something crazy. Let's take a look at this cell right here. And as I do that, I see I'm using B24 plus B25. Wonderful. That's my average of the bases, but I'm multiplying not by my increment anymore. And then I realize, of course, really common mistake, everybody does it. I should have made this B $18 and locked that B18 in place. And now when I replicate down, that's what I would expect to see. B23 plus B24 divided by 2, average of my bases times my height. Everyone has a height of our increment. And the nice thing is, if the increment changes, the height changes, our formula changes. So I could drag this guy down 10,000, but we know that if there's a column next to it that's already been drugged down that far, I can just go to where I would be replicating. I get the cross, double click, and that thing should be replicated all the way down. Okay. Now as I look at my last few values, everything's in the 0.018 range, and then we get this big departure. Let's take a look at, say, this formula. This formula is using my values that are in my chart. The next formula is using values that are beyond the 2, and the 2 is my x max. I don't want to go beyond the 2. I don't want this. This trapezoid is outside of the area I'm looking for, so I'm going to delete that entry. Then I want to add all of these entries up. I'm going to put it up above trapezoids, and because I don't like dragging 10,000 element charts, I'm going to note that my last element is in row 10,019. Okay, so I'm going to go back up to my top area, and I think right above here for now, we may move this in class, but right here in D18, I'm going to type in the formula equals sum, try again, sum, left parenthesis, and I'm going to start dragging out all of my trapezoids. But rather than drag down to 10,019, I'm going to cheat. I'm going to change what I drug to D24 to D10,019. Now, when I hit enter there, that should give me my approximated area. And if you have all of the parameters entered as I have above, including xmin, xmax, we should have the same approximated area. And that is a real checking point. You want to make certain that we're at the same spot for that. Okay. Then at that point, I might want to create something like another text or another text box, something like this. This is actually word art that tells me that, like Levi has done, the minimum negative 7.5, max 51 might have area 40.42 attached to this, but that's something we can take a look at in class. The important thing is with these parameters in place, you have that for an area. We could also, I suppose, since we're using this rounding convention, I could say for that formula equals round, comma, go to the end of the formula, comma, and hit my C16. And my area will be rounded to 4 places as well. That might be a nice thing to have. So if I change this guy to 3, we got it. Notice if I change my xmin, xmax, if I change my xmin to, say, 1, in 3, 2, 1, when I hit that, you're going to notice the graph change. You're going to notice the area change as well. 3, 2, 1. And there we have this area. That's the area under the blue curve, is 16.35. Likewise, if I change A to, say, 4, in 3, 2, 1, you're going to notice a little change in the graph, but you're going to notice a change in our area as well. 3, 2, 1. Okay, so a dynamic graph going to work for a lot of different polynomials up to 5th degree, certainly modifiable into others. We've got the workings here of something that's going to be very, very useful to you over the next couple of years of your math work in this class as well as in your calculus and beyond. So most important thing when you're working with Excel is remember to take time to enjoy it. It's just a beautiful thing.